section 9.5 is equations of hyperbolas. And, well, let's just jump right in and look at it. So hyperbolas are like two parabolas, only they're facing away from each other. There are two different equations for hyperbolas because they can be, if they're on the x-axis, that's different from if they're on the y-axis. And here's what happens. So if a hyperbola is horizontal, which means that it is the foci are on the x-axis, then your equation is going to be x squared over a squared equal or minus y squared over b squared equals 1. So it's always equal to 1, and then you're going to have your a squared is going to be the a is going to be your vertices here and here. This is where the hyperbola crosses the x-axis here, and so the positive and negative of this a, and then minus the b squared. The b is actually here, and the reason that's important, it's not going to be an intersection. You're not going to actually draw a line there, but we need that in order to create this rectangular shape in between, and then the lines that go through the vertices, the corners of your rectangle that is formed, those create the asymptotes around which your hyperbola are based. Okay, so the asymptotes then are y equals plus or minus b over a times x. Now, if you're looking in your book, they switched the a and the b if you've got horizontal or vertical, and for me that was more confusing. If you keep your b with the y, then it's always going to be b over a times x. So your asymptotes are y equals plus or minus b over a times x. So if you're going to use the vertical line, the y-axis, as your major axis, then you're going to have y squared over b squared minus x squared over a squared equals 1. So if your hyperbola is horizontal, then the x comes first, and if it's vertical, then your y comes first. And if you do a couple, then oh yeah, I'm starting to get it. So let's do a couple. Also, the foci. Now the reason for the foci in this case is, remember before we added those foci together, and that distance was the addition of those. In this case, the foci are, if you subtract the distances of the foci, then that stays a constant. So that's why the foci are going to be c squared equals a squared plus b squared. All right. So this trickiness, make sure that you've got the equation in your notes so that you can go back and look at it. And the more you do it, the more, oh, okay, I think I get it now. All right. So only two types of problems today. We're going to graph hyperbolas, and we're going to be given pieces of hyperbolas that we need to then just come up with an equation. So that's all we need to do. So start soaking in the equations and what they look like and why they look that way. So if we're going to graph it, in order to get that graph into standard form, we have to have, just like with the ellipsis, we have to have it equal to 1. So what we're going to do is we're going to divide this by 225 so that we have our equation equal to 1. Now, if we do that, remember, we can do that as long as we then do everything to both sides. So we're going to do the same thing to both sides here and all parts of both sides. So divide by 225. And 9 times 25 happens to be 225. So this is going to be y squared over 25 minus x squared over 9 equals 1. So this equation now looks something like, let's see, it's a y first. So it's this one. So it's going to be vertical. So my foci are going to fall on my y-axis. And we can also rewrite this to 5 squared and 3 squared. So what we're going to have is, on the y-axis, we're going to go up and down 5. 1, 2, 3, 4, 5. So there's a point here. 1, 2, 3, 4, 5. There's a point here. And then on the x-axis, we're going to go right and left 3. 1, 2, 3. There's a point here. And 1, 2, 3. There's a point here. Now, once we do that, what that creates is this rectangular shape. Okay, and with this rectangular shape, now we create the asymptotes by going across. And once we've done that, we know that because the y is first, we're going to use the 5 on the y-axis as our vertex. And so here are our curves for our hyperbola. It's that simple. All right, so make sure that you're just looking to see, is the y first or is the x first? And that's going to tell you if your hyperbola opens up and down or left and right. So if the x comes first, then it's going to open horizontally. And you're looking for these distances, the square root of them. The square root of them gives you the points that create the rectangle that then creates the asymptotes. Okay, that crisscross is your asymptotes. And then once you've got all of that, it's a quick, easy drawing your hyperbola. Now, it's interesting, it's important to know where the foci come from, because we're going to need to know that on the next one. So the foci, remember, is c squared equals a squared plus b squared. And we've got the a and the b. So we've got 5 squared is 25 and 3 squared is 9. So the c squared equals 25 plus 9 is what, 29, 34. So the foci is the square root of 34. Those foci are always going to fall on the axis around which the axis of symmetry. So the axis around which your parabolas are arched. So the square root of 34, square root of 4, let's see, 4 squared is 16, 5 squared is 25, 6 squared is 36, so it's between 5 and 6. So 5 and 6, so your foci are here and here. All right? All right. Let's look at one more type. This is going to be a quick video, but make sure that you're just going to have to do them over and over and over again. The hyperbolas, for me, are a little bit trickier because I have to actually go back. I have to keep going back to, now, which one is first and which one is second? All right, we're going to write an equation of a hyperbola with a foci of -8, 0, and 8, 0, and the vertices are -5, 0, and 5, 0. Now, if you'll look at this, and if you want to draw a little picture, that might help. So -5, 0, and 5, 0 are here and here, which says to me that the vertices are on the x-axis, which means that we're going to use this horizontal equation. So we're going to have x squared over something minus y squared over something is going to equal 1. So you've got the basic part of your, and now we said that the x squared is going to match up with the vertices. So we've just got 5 squared there. Did you see where I got that? Because the vertices. Now the y squared, the number under the y squared is going to be these, the places on the y-axis where our imaginary square or imaginary rectangle lies. So we can find that, though, by using our foci, because remember, c squared equals a squared plus b squared, and the b squared is what we want. So let's put in c squared. Now remember, c is the foci, so 8 times 8 is 64 equals a squared. 5 times 5 is 25 plus your b squared, and that's what you're looking for. You want b squared to be able to put it right here. So just subtract 25. And so 39 equals b squared. You can take the square root of 39 to get what b is, but in this case, you actually want b squared. So let's just put in a 39 here, and then just to make it uniform, you can change this 5 squared to 25, and this is your equation. All right, so not so tricky, really. You determine if you've got a horizontal or a vertical hyperbola, and then just put in your original, your x and your y, depending on which one it is, and then figure out, okay, do we have the vertices, do the vertices match up with the x or with the y? And put those underneath underneath the one they match up with, okay? So if this had been points, if the vertices had been points 0, -5, and 0, 5, then those would be the y values, and so those 5s would go under the y value in your equation. All right? All right, I think you can do this. No problem. I'll see you soon.